right. Good afternoon, everyone. Thanks for showing up my first talk. Harness the force for better penetration testing. My name is Patrick Fussell. If anybody finds anything I have to say today interesting, I'd be excited if you wanted to take a minute to look me up online. What I do, so I work for PSC. PSC is primarily a PCI compliance company. They do a lot of different services. So my main concern here, though, is penetration testing, because I am a penetration tester. Real quickly, some common ground for any other penetration testers out there. So like I said, this is PCI penetration testing, external, internal application. So this is tends to be goal-oriented testing, and I just bring that up so that you know where I'm coming from. I'm gonna try to be as general and applicable to everyone as possible, though. All right, so what's this talk about? As penetration testers, we ingest a large amount of data in limited time frames, and even when you start out with good intentions with how you store and manage that data, it's very easy to get tripped up and become less methodical and lose things. And what I want to do in this talk is review some strategies and some tools for homogenizing practices and capture data into an effective structure that helps ensure accuracy, security, efficiency, making sure that we can store and access data easily, and also making sure that we're still being thorough with everything we capture. All right, how are we going to go through this? I have a sort of a loose interpretation of the pen test execution standard, the phases that they define. We're going to go through each one of those, talk real briefly about some data points that get captured in those phases. And after we talk about that, we're going to go into a couple of strategies that are practices or tools that are loosely associated with that phase, and how we can apply those strategies. All right, so jumping right in, when does evidence collection start? So the answer for me, during any pre-engagement exchange with a client, right? So, and this takes a couple of different forms. This may be sort of, your official data collection standards. So maybe, this is just done by email, or maybe it's a form that they fill out with your, definitions of scope, dates and times, points of contact. But this also includes things that are sort of the less official notes that you take during meetings that will have relevance to an engagement. A couple of challenges to keep in mind here. There's a lot of variability in the formats of the data we can get. Even if you have a standardized approach to this, clients can often be creative in the way that they fill them out, so you don't always get the data you expect. Accuracy can really come into play here. Copy and paste errors of an IP range can cause a lot of problems, and being careful is a big deal. So things that maybe don't even seem critical right off the bat, they can be important as well. Contact info for an organization is a big deal. If you think something strange is going on in the environment, maybe you're causing problems with a system, you want to make sure you know who to contact in those situations. So I'm going to jump in with a concept I think everyone's probably already familiar with, namespaces, right? A namespace is just a way, or an idea, conceptually, a way of encapsulating items, grouping related files. This term is common in programming. If you write code, you've run into this before, but on a file system, you just call them folders, right? It's just a way of making sure that things that belong together stay together. A very simple concept, almost laughably obvious, but taking it for granted is, what I call the path of the dark side, where we store data in unintended ways, unintended places. We end up with data leakage and unintended retention of data. We're going to employ this idea a few different ways. In practice, this really just starts with defining a root namespace for a unique namespace for every engagement. It's simple enough. We can see a sort of a quick application of this on the screen here. Again, this is very simple, but a verbose command prompt, an effective namespace, make it really easy to look at a terminal, quickly identify where you are and what you're doing. There's a ton of really great ways to set up a command prompt. I only wanted to point out that it's something that you can have as part of your tool set, and it should complement what you're doing with your testing. Okay, root namespace defined for our project for this engagement. It's unique. We also want a structure for the data that goes into that folder, our namespace. It's easy and tempting to dump everything into the root. Maybe what you might actually want to do is wherever you are, you're going to run a command and leave the output there. But as you continue to test and collecting more and more data, ultimately it makes it much harder to sort, parse, find something that you just outputted. So if you've got 30 nmap files, even if you name them effectively, it becomes really hard to figure out which one was which. So my suggestion here, be detailed in how you set up your folders. And there's a lot of different ways you can organize them. You could do it by tool, by activity. I've got the two samples up here, and these are just sort of something I threw together to give some ideas. It doesn't really matter. You could do it by day of the week. Whatever you choose as a structure, you think through your methodology, your process, come up with a structure that works for you, and make sure that whatever the structure you pick is has a focus on being easy to navigate and descriptive at the same time. So another part of the setup is thinking about your virtual machines, right? And one thing I really want to focus on here is avoiding the cross-contamination of client data. And the reason I bring this up with reference to virtual machines is I think that the more ephemeral nature of a virtual machine has a tendency to, we spin it up, we spin it down, we delete them. It makes us be less cognizant about what we're storing on them, which sometimes is okay, but sometimes we end up with data sitting around for a lot longer than we meant to. We get that what I call the data leakage. We really want to make sure we're not storing data that we don't want sitting around. So one tool that's everybody's probably familiar with that you can use to help with this is virtual machine snapshots, right? A snapshot preserves the state of the data virtual machine at any point in time. This is a quick and easy way to create a segregated testing environment for every engagement. You build up a clean base virtual machine, create a snapshot for the engagement, name it appropriately, and then destroy it when you're done. And we've avoided a lot of that headache of making sure that we didn't leave files sitting around. Whether you store your data primarily on your host operating system or you work always in your virtual machines, take the time to set up some shared folders between the two that complement your process. So my approach for dealing with this issue is using a tool called Vagrant. If you're not familiar with it, it's essentially just a command line tool for building custom virtual machine instances from a base image. It's set up according to you define a configuration file that looks something like this, and you tell Vagrant to build your machine, and it does all the magic for you. So usage is pretty simple. This is just an example of what it might look like when you're spinning up a machine. You go navigate to the directory where your configuration file is, tell Vagrant to launch it, and a few minutes later you have your environment ready for testing. So why do I use Vagrant? It achieves some of the same things as the virtual machine snapshots and creating that segregated testing environment. At the same time, it's easy to respect the namespace of our project, right? So I can put that Vagrant, the configuration file that I use to interact with the virtual machine in the project directory. It also has a very customizable configuration file that makes it easy to have a consistent workflow for each project. We can quickly configure the virtual machine name, shared folders, install specific software packages, and there's lots of potential for automation of the creating and editing of the config file because it's essentially it's easy text to change. So you end up with something very custom to what you need with very low effort. All right, next phase, intel gathering. I've kind of grouped in OSINT, passive and active recon into this just for brevity's sake. Data gathering in this phase, it tends to set the engagement up for success, or it certainly can. For example, emails that we harvest during OSINT and some custom password lists might mean you find a success where you otherwise might miss something. Understanding what hosts are active, have services belong to which VLAN can be a really daunting task when taking into account the number of systems that might be active on a large network. So there's a lot of things to think about in this phase here. One method I found that useful for helping ensure the consistency and efficiency here is Scripting and automating any repetitive task as much as I possibly can. So anywhere I can reduce the number of steps for doing something the right way, I'll take the time to do that. And some examples might be opening terminals, accessing data regarding a specific project. Anywhere I want to make sure I'm respecting the namespace of the current engagement. My personal approach to this has been a handy little tool called Thor. If you've never seen Thor, or if you've ever used Metasploit, I believe it uses Thor to build its command line documentation. Essentially, Thor is a Ruby toolkit for building command line interfaces, but also it has a nice little command line tool itself. The Thor command line tool will take a file where you define some tasks in Ruby and turn it into a full-featured, or turn into a command line app that has built-in usage documentation. This makes it very easy to quickly install or remove applications. And what this really means is you can quickly build and deploy a fairly robust command line app on the fly. And how might we use this, or why is this useful? I use Thor programs to do a lot of things, simplify interaction with projects and its files. And on the screen you can see a couple of tasks that I've defined with Thor for interacting with my projects. And this includes project creation, opening terminal windows. In particular, I want to show the show function here. This is obviously a simple example. I'm sure that if you, in a real engagement, you're probably going to see a lot more ranges than this. But it's what I want to do is make it very easy to say, for a given project, show me some data set. And I try to be inclusive with this, so have lots of different pieces I can show myself very, very quickly. Contact data, IP list, if there's a list of hosts that I'm not supposed to scan, give myself quick access to that data so that I'll always have it on hand without having to take time to go look it up. One thing I mentioned about, I use Thor to open up terminal windows, and one of the reasons that I do that is I want to make sure I'm always logging my terminal sessions. So one of our goals is to be thorough, and we'll make sure that we, logging our terminal sessions, it certainly helped achieve that. It's really easy to forget to add a pipe out to something, or add that flag to make sure we save our data file from a command line tool. And you say, well, I'll just go back and copy and paste that later out of the terminal and make sure I get it into a text file. But relying on yourself to do this increases the chance of forgetting something, missing something. Your terminal dies, you forget to set scroll back, whatever happens, your data disappears, and now you have to either rerun it, or maybe it's something that's gone forever. I think that the script command is something that's fairly ubiquitous for most Linux users, but in case you've never heard of it, essentially it's a very simple command. You tell it where you want it to save your console session. It does it. When you're done, you type exit, and work is done. And additionally, you've got in PowerShell, we can use the start transcript command that achieves almost exactly the same thing. All right, next phase. So I grouped exploitation and post-exploitation together, again, for brevity. This is, I know for me, this is where things have a tendency to get messy. Once I gain a foothold, I tend to want to chase the hack, where you get excited, you've got your first access, you're trying to escalate. It's easy to let that get away from you. And what we end up doing is opening lots of shells. Maybe you sprayed shells and you've got 30 open, or maybe 100 or 200. Or maybe we're managing multiple network pivots and trying to remember what's going on where. It is exciting, but we're not careful. This causes a lot of problems. Rushing makes it hard to recreate what you've done. And in turn, increases the amount of time you need for reporting, and muddles up any communication with the customer, especially if it's communication that's happening during the engagement. All right, so one easy solution for this is logging a descriptive summary of your significant actions inside of that pen test. This is a practice that was born of a requirement from PSC. They required that we keep a chronology of activities during each engagement. And so over the years, I've kind of expanded this into a much more robust practice that's very specific to the way that I work. Now, I do want to mention this process can reach back and it affects other phases of the testing, but I find that it becomes the most significant in that transition between intelligence gathering and exploitation, when you tend to start to accelerate the pace of what's going on. The practice keeping running log testing activities is simple, right? Something that you think is going to matter happens. You take a note of it, and then I know what I like to do is either capture some of the most relevant output or just notate where I've stored the files that are related to it. This does a few things for us. Builds strong situational awareness of where you've been and where you're going. It forces you to slow down a little bit, think about what's coming next, and aids in streamlining the communication with the customer about what's going on during the engagement. It's also really handy when it comes to cleanup. You can notate any shells that are open, files that are dropped, accounts that are created. Makes it very, very simple to go back and make sure that those things are remedied before you leave. So what you can see on the screen here, this is actually Emacs. If you're not familiar with org mode, it's essentially just a handy Emacs major mode for taking notes in an outline. Very easy to navigate headlines. So what you see in yellow there are the headlines, and then you can expand or contract anything that's underneath one of those, and you can have subheadings as many as you need. So it's very flexible. It's very easy to navigate, and it makes it easy. If I compress everything inside of all of the headlines, it's very easy to read and essentially have a narrative of everything that's happened. There's also other tools that you could do the same thing with, Magic Tree, Evernote. I'm sure that Vim probably has something similar because they always do. All right, final phase of testing. So the good news for this part is these practices tend to be cumulative in their benefits as you progress. If you took the time to be really diligent in your evidence collection, the other phases of testing, the reporting becomes very, very easy. And I do want to touch on one final little tool to help kind of tie all this together, and that is graphing the narrative. So if you've ever tried to sit down and explain the actions that happen in maybe some sort of complex post-exploitation scenario to someone, you can even get confused yourself, even if you're the person who did it, because you're talking about lots of lateral movement, and describing how those things relate to each other can get really hard to track. So I started off just by drawing, and I'm a really terrible artist, so that doesn't work great. But there's a tool called GrrCON that will help solve this. So quick intro, just to touch on what it is. All GrrCON is a visualization suite. It comes with several layout programs. It takes the description of graphs in a simple text language and draws a graph for us. In the figures, you can sort of see we have these are our nodes here, and then you can see our little arrow there just tells us the relation, and we tell GrrCON to draw us a graph, and it does all the hard work for us. This is an exceptionally simple example right here, because GrrCON can do lots and lots of fun stuff, but at the same time, it's very easy to pick this up and have something that works for you right away. Just as an additional side note, I use the Atom text editor because it's got a great little extension that will live render these graphs for you guys are drawing them. And so combining this tool with our sort of running narrative of our testing makes you very, very aware of exactly what's going on, and then makes it easy to describe to anyone who wants to know how you got where you got during a pen test. All right, so what's the takeaway? Our practices around how we collect data, anything related to a pen test should ensure that we are, all our data is accurate. We want to be able to access it efficiently. We make sure it's thorough, and obviously we want to make sure it's secure. Do a quick review of your own methods, your own practices, and make sure that that you're trying to, or that you're achieving these things, and hopefully some of the tools and the practices I went over today to maybe improve some of the things you're already doing. Thank you very much.